Okay, next we'll see relative velocity equation. The last lecture we saw that relative velocity equation. Consider the velocity of the moving object P is Vp and the velocity of the moving object Q is Vq, and Vp given Q is the velocity of P as Q as observed. Right? So now velocity of P can be expressed as velocity of P given Q plus velocity of Q. So this is the equation we are going to use to solve some problems. Okay. So velocity of P is velocity of P with respect to Q plus velocity of Q. Look at this diagram. Let's see, this is the velocity of P with respect to Q, and this is velocity of Q. So then the sum of these two is nothing but velocity of P. Look at this example. A straight horizontal moving walkway. See, the walkway is shown in the diagram. Travels at 1.5 meter per second in the direction from a fixed point A to B. It's from west to east. The walkway speed is 1.5 meter per second. So this we can represent velocity of W, VW, let's take, which is velocity of the walkway, which is 1 meter per second. A man walks on the walkway from A to B, and he's walking on the walkway at 1 meter per second. Is walking on the walkway, which is 1 meter per second. Let's take velocity of the man. Let's take Vm. This is not the true velocity. This is velocity of the man with respect to the walkway. So this you have to write Vm given W. What is called true velocity of a man? True velocity always the velocity of the moving person with respect to the ground. So this velocity 1 meter is on the walkway, and the walkway is moving at 1.5, sorry, here it has to be 1.5. The walkway is 1.5 meter per second moving, and the man is moving 1 meter per second. Now if you have to find, the first question is find the velocity of the man, the velocity of the man relative to the walkway. So that's what this velocity of the man relative to the walkway is 1 meter per second. And what is the true velocity of the man? So that is nothing but Vm. Let's use this formula. If it is V, if you have to find Vp, is nothing but Vp given Q plus Vq. Same thing we are going to find. Vm is nothing but velocity of the man with respect to the walkway plus velocity of the walkway. Velocity of the man with respect to the walkway is 1, and this is 1.5, so which is 2.5. 2.5 meter per second is the true velocity of the man. That is the velocity of the man with respect to the ground. Let's consider if the velocity of the walkway changes, and if the velocity is 2 meter per second, so then again it is 1 plus 2, which is 3 meter per second would be the velocity, true velocity of the man. That is the velocity of the man with respect to the ground. So here you can make use of the velocity equation. That is this. Okay, so this equation you can use. So this you can call it as relative velocity equation. Right? So let's recall. Vp is nothing but Vp given Q plus Vq. Alright. Now let's consider the other example. In the diagram, a river is flowing at a speed of 3 meter per second. See, this is the river, speed shown here 3 meter per second, and the boat, a boat having 5 meter per second in the still water It's moving upstream. Note on the term upstream. Okay, hope you know the difference between upstream and downstream. So this, the water flow is from west to east, right? The water is flowing from west to east, and the boat is on upstream, that is, the boat is moving from east to west. If it is downstream, it goes along with the water flow. So now the question is, find the true speed and the actual direction of the motion of the boat. Here the boat is moving 5 meter per second. This information we can represent. Let's take VW is the velocity of the water, that is 3 meter per second, and let's take VB be the velocity of the boat with respect to the water. It's not the true velocity given. It is in the water, the speed is 5 meter per second. Now if you have to find the velocity of the boat, velocity of the boat is nothing but velocity of the boat in the water, in the still water, plus velocity of the water. Right? Here, this is happening in the opposite direction. It is in the upstream it's happening. So velocity of the boat in water is 5, and plus of this is in the opposite direction, you can take what? -3. So if you're standing on the river bank and observe here, for an observer, the boat moves at 2 meter per second only. Even though in water it is moving 5 meter per second, and the water is flowing opposite to the boat movement of 3 meter per second, the true velocity of the boat, that means the person who is standing on the bank, river bank, and observing the boat, according to his observation, the boat is moving at 2 meter per second. So here you can make use of the equation. Now let's consider another example. In an international airport, a straight horizontal moving walkway travels 8 meter per second in the direction from the fixed point A towards the fixed point B. A passenger P walks from A to B on the moving walkway at a speed of 1 meter per second. So this person P is moving 1 meter per second. At the same time, another passenger Q walks from B to A. There's another passenger down. He walks from Q to A on a fixed horizontal ground. He's not on the walkway. The person P is on the walkway. And he's walking at the speed of 1.2 meter per second. Calculate the velocity of P. What's the velocity of P? Velocity of P here stands for the true velocity. So true velocity of the man is nothing but his velocity plus the walkway velocity. So you can take the walkway velocity is 0.8 meter per second. The person P's velocity is 1 meter per second. Right? So the true velocity of the man is 1.8 meter per second. So that's your first answer, that is VP. Now the second question is the speed of P relative to Q. Now, if Q is not moving, according to Q, P's speed has to be 1.2. But Q is again moving. Q is moving opposite direction. That is from from B to A he is moving with 1.2 meter per second. So this is called relative velocity. The relative velocity of P according to Q can be written as P given Q. That is 1.8. That is the true velocity of the man on the walkway A, and this is the velocity of the true velocity, in fact, true velocity of the person Q. So this 3, if you add these two, you will get 3. 3 is nothing but the relative velocity of P with respect to Q. Right? The last part is distance AB, the distance between A and B, the position A and B is 120 meters. Suppose P and Q pass each other after t seconds. Find the value of t. Now it's very simple, same like the previous case we have done the previous lecture. There is time is nothing but distance upon the speed. The distance is 120 and the speed is 3. This is the relative speed what we calculated in the B part. So if we divide, they'll cross each other within 40 seconds.